Hello all, welcome to my channel. I'm back with another video. This is the part 2 of the series that we are doing on Ray. In this video, we will be looking at Ray from a Spark developer's point of view. This makes easier for us if someone is coming from Spark background, they want to understand how Ray works. It will be a good video. So let's see what uh, how it will look from a Spark developer. So if you are a Spark developer and so you already know that okay how Spark uh, powers the distributed data processing. So it has been a go-to framework for unified analytics on massive data sets because it distributes the data sets into parallel chunks and then operates the same code on those things by running multiple executors on different cores. So this is how uh, uh, this is how Spark works. From that point of view, Ray is something slightly different in a sense. It does not operate on distributed data sets, rather it operates on a parallel function, or we can say it flips the model by running it, making the code more parallel than the data sets itself. So Ray is an open source unified computing platform designed to scale Python applications for general distributed computing. Ray treats distributed execution as a natural extension of single node Python code. For example, if we want to, let's say if you have worked with Spark and let's say you have created a pandas data frame or pandas from code you have. The moment you have pandas code, uh, it's a single node code, so it cannot be parallelized, and Spark cannot Spark has to bring all the data to one particular node. So if you have seen, there will be many cases where people will say that okay, don't say two pandas from Spark data frame because that brings everything to one single node, and generally that will cause an out of a memory error because it tries to bring everything to one particular node because that system is built in such a way that it is a single node system. But Ray treats it differently. Ray makes those single node systems work in distributed fashion. That's what the power or the what you call excellence comes into picture. Uh, Ray excels in dynamic and heterogeneous workloads, like it can help us with parallel hyperparameter tuning on actor-based simulations. So this makes it ideal for an AI-driven apps. So in this, we have we will see how Ray and Spark are related in terms of their computation model. So in Spark, how things work is we have a driver program which a user submits. When a user submits a code to cluster, driver program comes up. It will talk to cluster manager to request the resources, and then once it has the cluster manager or the resource manager will launch some executors on worker nodes. Let's say worker node 1 and 2. So executors are launched in here. Then driver will distribute the task and send the task to both the what you called executors. Executor will execute the function that was asked to execute it and then send back the results to the driver. So this is how an Spark works. In case of Ray, the user will submit a job to the Ray cluster. The driver, which is user's job, will talk to the head node where the application master will launch. And then this head node has other stuff like autoscaler and other information. So what it will do, it will see that okay, we need certain workers. If not there already, so it will create that worker. Then it will send that actor model will send that function to these remote executions. It will use the shared object store to get the shared data, and then it will start the processing and send back the result. So that's how it is similar, but the concept is very different. The relay concept, which is the local scheduler on a particular node, and the worker processes which are running. So as I was mentioning, so Ray follows data parallelism. Sorry, Spark follows data parallelism, while uh, Ray follows task parallelism. So the fundamental difference is their execution model. So Spark is built to apply same operation across many partitions of a large data set, while Ray is designed to execute many independent arbitrary Python functions concurrently. It's a general purpose framework for scaling almost any Python application. So that's how the models are different. So let's say there is an ETL for code. So here what we are doing is we will have one code which simply reads a CSV file, does a filter, group by, and then writes the results. So if we write this in Spark, we will be writing like this. We will sort of initialize the session. It will read the data set using spark.read.csv. It will filter based on certain column, aggregate the data by doing group by, and then we will aggregated results will be written back to Parquet files. This is what how a ETL code will look like. In case of Ray, we will use Ray dataset, which is a scalable pandas like API on top of distributed data processing that happens. So again, Ray dataset also supports lazy transformation, automatic parallelism, and seamless integration with Ray's task and actor system. So no JVM Python overhead because it's all written in Python. There is no JVM Python interaction happening. So what we do is we import array, we import array data as a data set. So we initialize this, we read the data. So array dot data dot read CSV, and then we say filtered CSV. We again create a filter. Then we compute the group by function, which is average, calculating the average based on the product. Then we call this group by function, and then return the aggregated results to the data source. So see how it is pretty much similar to how Spark is written, by Spark code is written, because this is also Python, this that also is Python, but now from the syntax wise we are almost similar. So this is how the difference is in the way that gets executed. So Ray pipeline is declarative but leans on Python functions for transformation. It's easy extension for custom logic and everything. For example, we can use NumPy and PyTorch in here, but that would be difficult for Spark to do. And under the hood, the pipeline operations, they minimize the shuffle. There is not that much shuffle that happens in Ray. It's because it supports dynamic resource allocation and a mixed, and also it has a shared object store. Plus, the other thing is that it supports dynamic resource allocation. Like we can mix and match CPU and GPU tasks in the same code. This is one another example or another flow wise if you see. So DAG scheduler optimizes the plan. Then it says, okay, the executor will read the CSV. Then while doing the group by, it will send the data across to the other executor. So that's a shuffle part, which will create a shuffle exchange, and then aggregated results will be written out to the output. But in case of Ray, the GCS task graph resolver creates the task set. It will filter, it will have filter task, map on blocks, and legit transform. It will have object reference. It will do the group by. There is no shuffle actually involved in Ray's execution mode. So that's one particular difference. So Spark's stage is optimized for batch throughput, while Ray's graph supports low latency stateful dependency. That's what it does. So these are some of the commonalities or differences between Ray and Spark. So hope this was helpful. If you need any further help on this, read the blog in detail. Also, you can go through the Ray and Spark documentation to find out further. So hope this was helpful. Uh, enjoy watch. If you enjoy watching these videos, do share it and show some appreciation if any. Thanks.